we can do with this. That this is equal to
Another corresponding.
this, because it's another corresponding angle. So you could be told that this is 115 degrees and asked, well then what's that? 65 degrees. Because they're supplements.
And
Okay.
you can find out the top angle of that triangle.
And once you know these two angles, then you can find this one because the three angles of a triangle add up to 180 degrees.
80. Why is it-
Okay? So that's a bunch of stuff we can do with that theorem.
What's
All right.
What's the midpoint of that one side of the triangle? Like where?
Okay. The midpoint of one side would be this. All right? Parallel to another side would be this one. And the midpoint of the third side would be this. Okay? But the fact is, you can draw that line anywhere on that triangle. I could draw a line connecting the midpoint here and here. Oops. All right, I could draw a line going through the midpoints of these two. And this line will be parallel to this one, right? And it'll be going through the midpoint of this one. So I could also draw one coming where? There. All right.
It doesn't have to go through both. Like that.
Doesn't have to do what?
Go through both of them. Like what? Like the blue and the
Right. It can go through any two midpoints.
So it has to go through two.
It has to go through two midpoints.
So
Either these two, or these two, or these two. Okay? And then the left outside is the one it's parallel to. All right. Now, this is where you were supposed to have your rulers. Who does not have a ruler today? The majority of the class.
Oh, no.
Glad y'all listened to instructions.
I remember.
Thank you, Elise, for bringing your ruler today. All right, this is a protractor, a compass, and a ruler all in one.
I don't have one.
Thank you, Lauren.
I'm a school.
Okay, now today we're just going to be using the ruler part of this. In order to, oh man, class is almost over. All right, I want you to draw one triangle. I want you to draw an equilateral triangle. What's that mean? All sides are equal, okay? Try to make it an even 2 inches or 3 inches, where all sides are either 2 or 3 inches. Have an equilateral right triangle. But that's fine, just draw that one and measure it. That's fine, just finish that one off and measure the sides. You can do that too. If it doesn't come out perfect, just take the measure of each side, whatever it is, and I want you to put it next to that side. If it's 1 inch, put 1. If it's 2 inches, put 2. If it's whatever, put it. So measure the 3 sides. Now I want you to find the midpoint of each of those 3 sides. Using your ruler, try to have pinpoint accuracy. The midpoint is the exact middle. See if you can find the exact middle of each one of those 3 sides and put a dot.
What's the midpoint of 1 and 1/2?
3/4. Halfway between half and 1. All right, now that you have your 3 midpoints, I want you to connect them using line segments like this and draw a triangle within your triangle. Once you've joined your midpoints, I want you to measure each new segment. Write down your measures and then look at your picture and tell me what you notice. And don't yell it out. Measure each little segment. Here's a picture of kind of what you should have done. Measure how long is this, how long is this, and how long is this. You know? There's two things you're supposed to figure out. If you figured out one, good. See if you can figure something else out. And it's not really complex. It's just kind of look at it. Hannah, what did you see?
That it is half of like the other ones.
It's half of the third side, right? Each one of them, if you measured them carefully, should be half of the left outside. Something else is true about them. Look at each line segment and the side that it's not connected with. What do they look like?
There's 4 equal triangles.
There are. But what I'm trying to get to is this. They're parallel to the third side. They are parallel to the third side. So our last theorem of the day says this. The segment that joins the midpoints of two sides of a triangle. Now we already said this in the last theorem. It's parallel to the third side and it's equal to half the measure of the third side. Now I'm not talking degrees, I'm talking length here. So it's parallel to the third side and it's equal to half the measure. Now we can use this in all kinds of ways. If you know that you have a triangle and this has a measure of 10 and this has a measure of 5, what do you know automatically? Since this is half of 10, these must be the midpoints. Which means this and this is equal. Which means this and this is equal. And it also means that these are parallel. Which means corresponding angles are equal. There. And there. Look at all the information we just got from that right there. Okay? Yeah. Any one of those lines. Any one of them. Suppose I had said it this way. Suppose I just said this. And I gave you that the measure of this was 4. Well, that means if this is parallel to the third side, and I would have to show that at least one of these has been bisected, then I know that this one is also bisected. I know that this is twice as big. And since they're parallel, corresponding angles. Isn't that the picture I just drew? I'm sorry.
Well, but just by knowing that it's 4, you don't know that it's parallel. Though.
Right. You have to know that it's parallel and through the midpoints. Or if you just know it's through the midpoints, you automatically know it's parallel. Okay? Homework assignments on the board.